am sharing my screen. Oops. And before I do that, let me open the chat. Let me reopen the chat. Okay, so today is November 17th, and the goal of the day is to review. Project 3 is going to be due a week from today, Tuesday, the 24th. I apologize, but the paperwork with it says the 23rd. That's for my Monday, Wednesday, Friday class. For you guys, it'll be due on the 24th. Exam 3 will be due on the 22nd. By the end of the day, Sunday, it'll be available for you starting tomorrow. Before I forget, I had said that I wanted to add something that I had forgotten to add to class for today's notes. I apologize. I should have done this earlier. But I was running around taking pictures of my backyard.
It always pops me out.
Oh, I'm sorry.
No, it's not you. I don't know why.
So let's go back. Z-score, we said, was equal to the data value minus the mean divided by the standard deviation. So let's say, for example, I'm looking at an SAT exam where the mean is 500 and the standard deviation is 100, and I want the percentile of a score of, oh, let's say we did really good, 750. Well, the Z-score for 750 would be the data value, 750, minus the mean, 500, divided by the standard deviation. So that would give me 250 divided by 100, or 2.5. Michael, with me so far, is that okay?
Yes, but what about, like, because for the homework it's saying like 5 feet 6 inches tall, so I'm assuming I just convert that all to inches and then...
Right. But what you have to remember is 5 feet is 60 inches.
Right.
Because
So
there's 12 inches in a foot. So 5 feet 6 inches would be 66 inches.
So then, for example, the question says, in a certain study, women's heights are found to be approximately normally distributed with a mean of 65 inches and a standard deviation of 2.5 inches. So that would be 66 minus 65 divided by 2.5.
66 minus 65 divided by 2.5 would be 1 divided by 2.5 would be 0.4, I think. Can you check my division?
Yeah, hang on, let me grab my phone.
I got it, 0.4. And so then if you want the percent at or below, that's when you have to go and look at the table. And
Okay.
so for my example, I'll do that one first. A Z-score of 2.5 would correspond to the 99.38 percentile. As opposed to with yours, with a Z-score of 0.4. 0.4, that's 0.40 corresponds to the 65.54 percentile.
Wait, say that again, I'm sorry.
If they
Hang on, let me try to make a video.
If they ask what percent is at or below that, we've got the Z-score to find the percent. We're going to go to this Z table.
Yes.
And so I'm going to look up your percentile was 0.4, which would be over here 0.40. And so that's 65.54%.
Okay, thank you. I'm really glad you said that because I was totally spacing out and going with 4.0.
When you go to the, be careful, watch your decimal placement with these. So, okay, so I'm going to go back to that front page. in terms of reviewing today, one of the things that I wanted to make sure we did first was answer any questions that anybody has on any homework. And so before we do that, somebody just entered the meeting. Who just entered the meeting, Ali?
Yeah, I did.
Okay, I got you're here.
Yeah.
Before I forget. Does anybody want to look at any homework questions? I have the homework open. I'm more than willing to look at any of the problems. Wow. Total silence either terrifies me and tells me that you haven't started doing the homework yet, or flip side fills me with joy that you were all able to attack those problems without a concern.
I'm actually doing the homework right now, so you helped me with number one. So I really appreciate that because, like I said, I'm still waking up and I was totally spacing on how to do the source stuff.
Okay. Well, if we're not going to look at any specific homework questions, next thing I'd like to look at is where you're going to find that project 3. And so I'm going to go into Blackboard. In Blackboard, I don't know if you noticed, I have a tendency to put everything in that tab for content. In my mind, content is kind of where you store stuff. And I've tried to put folders to organize them. So if you go into that folder for projects, project 3 is, oh, it's not dues, it's due November 24th. Yes, in my next slide, I'll be able to type. If I click on the project, it'll open as a Word document. And so for this project, I want you to go to either the Bills, the Sabres, or the Bison's web page and find player statistics. You can pick any statistic that you find interesting and record that for any 10 players. You can pick the 10 players you want any way you want. I don't care what statistic you use. If you go to the Bills site, the first statistics that I found about the players were just about the players, things like their ages or their heights or their weights. And then if you go into player statistics, they have things like, you know, how many yards they got, things like that. If you're much more into like the sports, I think the defensive players, they have like how many sacks and things like that. If you go to the Sabres website, you can get comparable things, and they have like, you know, how many points they scored, their plus minus, which I don't really know what that means because I'm not a hockey person, but they have all sorts of statistics about them. Go to the Bison's website, there's all sorts of baseball statistics, you know, their batting average, this, that, and the other thing. Just get 10 players and data about them. I had wanted to try to include the Buffalo Beauts to be kind of a little bit more fair in terms of, you know, getting the women's sports in there too. But when I looked at their website, all of the player statistics were zeroed out for the upcoming new season, and they didn't have any statistics from the prior season. If you are not a sports fan and you don't want to use data about athletes, that's fine too. Just make sure that it's clear to me what data you're using and where you got it from. So that I guess if you were like really a political type person and you wanted to do something on that last election, you could get something like the percent of the electorate that voted for the candidate of your choosing in 10 states of your choosing, or in New York State in 10 counties of your choosing. I'm just looking for you to get a data set. I, in the spring, when we went fully online, I used the sports teams because I knew that that data was easily accessible for students. Previous semesters, I had people survey people to get their data values. But again, in times of COVID, it's not as easy to survey people as in when everybody was on campus. But basically, you're going to get a data set with 10 values and make it clear what the data set is from. You're going to represent it graphic. So coming up with your data set is 4 points. Then representing it graphically, You need to make a histogram and you need to make a stem and leaf diagram. Those are worth 6 points. Then you're going to find the measures of central tendency, the mean, median, mode, and mid-range. Those are worth 6 points. You're going to compare them and say which one you think is better describes your data. Then you're going to find the standard deviation and tell what that means. That's worth 4 points. You're going to turn in the list of your data, the graphs you created, the work for the computation that you did. So I don't want anybody to just put the numbers in a software package and get the mean, median, mode, mid-range, and standard deviation. I do want to see your work in getting those. Same way, I know that at the high school level, there are people who might have learned how to find the standard deviation by putting the numbers in a list in a graphing calculator. That won't suffice. I want to see your work. And also you need to write a report summarizing. The report is worth 5 points. And so it shouldn't take too terribly long. Again, I suggest the sports teams' websites to get the data because it's easy data that you might find interesting. If you don't find it interesting, you can use other data. Just make sure you have a data set of 10 and you find all of the parts. When you're done with it, you can type it if you want. If you have it typed, great. If you want to write it by hand, fine. You're going to submit it in this Dropbox here. When you submit it, if it's written by hand and you want to take pictures, great. If it's typed and you want to just upload the documents that you typed, that's fine too. Just a heads up, going back here, with either of these, when you submit your work, if you submit pictures, if you have an iPhone doesn't play real well with Blackboard. You have to make sure you're using the Blackboard app. And no matter what you use, whether you're using an iPhone or a computer or a tablet or an Android, make sure you save your work and you save your pictures, because sometimes when I look for people's work, I just get blue dots that says it's still being submitted and I can't open those. If that happens with you, I will send you an email asking you to send your work to me via email, because I can't access what you put into Blackboard. Any questions about the project?
When did you say it was due?
A week from today.
All right, thank you.
Then in terms of the test, this test is going to be different than the preceding tests. This test is not in my labs. This test is in Blackboard. So if you go into Blackboard, in content, to tests and quizzes, there's a separate folder for exam 3 on statistics. There are 3 things in here for you in case, because I remember when I had tried to put my own quiz in Blackboard, diagrams didn't always show up. And so the one diagram that you would need is the Z table. So I have that in there for you. In addition, there is a drop box for you to submit your work, submit pictures of your work. For some of the questions, I ask you to draw a diagram like the, the normal distribution. You can upload your pictures and put them in here. If you make a table to find a standard deviation, you would upload it here. Please notice it's not worth very many points, the work, because I'm going to mostly put the grade in with the test. And the test itself is over here, exam 3 statistics. Please be careful with Blackboard tests. Once you click on it, once you open the test, you have to finish it. So don't click on it and think I'm going to come back. No, you've got to finish it in one sitting. So don't click on the test itself until you're ready to take it. Did everybody hear that? Don't click on the test itself until you're ready to take it. With the test, whoops. Now, why isn't this allowing me to scroll? There we go. With the test, you get 75 minutes. Once you click on it, once it's open, you must finish it. You only get one chance. And if there are any problems, email me immediately. And we'll try to take, from the technology side, we'll try to take care of it. If you open it and things aren't clear, if diagrams don't show up, get a hold of me immediately, and I will try to rectify that for you. That test is scrolling up back to the top of the page. It's due on Sunday, the 22nd. So that if there are any problems with the it being in Blackboard as opposed to in my labs, we can clarify them on Thursday. So does anybody have any questions about the logistics of the test?
Which era is the test on?
Say that again, I didn't hear you.
What is the test on? Which chapter?
It's on the statistics. We're going to go over a practice test as soon as we're done talking about problems people might have. Okay? Any questions? If not, I'm going to ask everybody to get their handy dandy calculating machines out. And I am going to look at this review. And hopefully we have time to go over the whole thing. The review is pretty close to the test. There's just one question that's not here, but what's on that question is covered with these questions. And hopefully it's interesting. It asks for information about yourself. So everybody ready to go over this? Okay. So what we've got here, question 1, the grades for a class on a quiz for 2010, blah, 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 blah. I ask you to make a frequency distribution of the grades with the class, first class being 5 to 9. Does everybody remember what a frequency distribution is? Does anybody remember what a frequency distribution is? Can you guys hear me all right?
Yes.
Yeah. It's basically a sort of organization of data that shows us how many times a certain value appears in a set of data.
Yep, it's just a table organizing the data. And so the classes would be the quiz grades. The first class is 5 to 9. So then the second class would start with 10. And this difference shows me that my class width is 5. So 9 plus 5, it would be 10 to 14. Then adding 5, 15 to 19, 20 to 24. And then I think there's a couple scores of 25. So let's add that 25 to 29. When you make the frequency distribution, it's a matter of personal preference if you want to put in a tally or not. The other section yesterday asked to include a tally. So let's use a tally to count our values and then record the frequency. And so for the tally, my first score is 20. So that would be in the group from 20 to 24. Then I have a 10. Then I have a 9. Then an 11. Then a 14. Then a 25. An 18. A 12. 14, another 14, a 23, 15, 22, 23, 10, 22, 25, 15, 23, 13, 15, 23, and 8. You don't have to cross the values out as you do it. I just know that sometimes I lose track of where I am in a list. And so it makes my life easier to do that. Not quite done yet, though, because this shows me the tally, not the frequency. This first class would have a frequency of 2, the next one 8, the next one 4, then 7, then 2. And so that table with the frequency distribution. Doesn't frequency distribution sound a lot harder and more involved than what it really is?
Yeah, it does.
It sounds so eloquent, and it's like, oh, I'm just making a table of how many there are. Is that easy enough for everybody? This is like a 10-point question on the test. Are you all getting those first 10 points?
Well, I know I did wrong in the homework when we had this.
Well, I think if you, on the pencil and paper test, if you kind of like cross it out as you go, it'll keep you from making careless mistakes. And always remember, we want these class widths to be consistent.
So for the 5 to 9, that's what you start with?
Yep.
Okay. And then you go, okay. Good.
Next one asks us to make a stem and leaf plot of the grades. Stem and leaf plot, again, isn't that difficult, but there are some things that you have to do. When I do a stem and leaf plot, every time I make one, I actually make 2. Does everybody remember stem and leaf plot isn't that different from a frequency distribution? It organizes my data, shows me how many scores I have in different ranges. And here we usually do them in groups of 10. As I look at this, the lowest score is in the 60s, and the highest score is in the 90s. And then do you remember, first score is an 85. So next to the 8, I'll put a 5, and that represents 85. Then I have a 61, a 61, a 76, an 80, an 86, an 83, a 60, a 92, an 87, a 68, a 90, a 65, a 93, 75, another 75, a 71, a 76, a 63, an 88, and a 96. That's my sloppy copy. That's not my final product. For my final product, I need a title, test grades. For my final product, my stems are in order 6, 7, 8, 9. I want to put my leaves in order. And so if I look at the 60s, the lowest would be 60, then 2 61s, a 63, a 65, and a 68. Putting the 70s in order, I have 71, 2 75s, and 2 76s. Putting the 80s in order, I have an 80, an 83, 85, 86, 87, and 88. And putting the 90s in order, I have a 90, a 92, a 93, a 96. So I do want you to put the data in order. And I'm still not quite done yet, because I know when we first did stem and leaf diagrams, some of you people said you weren't real sure, you hadn't seen one before. And so if you haven't seen one before, what helps you understand what it's all about is a key. And so for my key, I can pick any number on my stem and leaf diagram, let's say 6A, and I'm going to write that that means the number 68. Just to try to give meaning for this diagram to people who might not be familiar with it.
I do have a question.
Sure.
Did you want us to put like commas between each number or no?
No,
Okay.
no. Usually a statistician will not put a comma in between the values. Sometimes the software, like MyLab, just put a comma in between to kind of differentiate between them being single numbers and not one big long number. But technically, you're really not supposed to put those commas in there.
Okay.
How's that stem and leaf diagram? Is that easy enough for everybody?
Yep.
If you wanted to do a quick check, what you might want to do is you might want to count the number of leaves that you have and make sure that the number of leaves is equal to the number of the other values. Make sure you didn't skip anything. I think the biggest problem with these is sometimes people skip a value. So,
Excuse me, I have a question.
you
So
do.
based on how I read that, I just read that to make a stem and leaf of the grades.
Mhm.
I didn't read that you wanted us to order the grades, like how you just did the second stem and leaf.
When we defined a stem and leaf diagram, we had said in our definition that the leaves are always in order.
Okay, so I went over this with my tutor yesterday, and he was like, "Oh, just put the stem and leaf, just put the chart together."
Which we had, when we defined them in class, we had said that the leaves should be in order. And we had said that whenever we do any graphic display, we need to have a title on it. And with the stem and leaf diagram, a key is important to rate it. I mean, if you've got your stem and leaf diagram and everything is right and your leaves aren't in order, you'll get like a 9 out of 10.
Okay, so we always put a title, a key, and put it in order.
Yes.
Put in order. Okay, thank you.
All right. Thanks for asking.
I'm glad I did. My tutor was.
Well, maybe other professors don't expect them in order. I've always been taught that you should put your leaves in order because honestly, I think this is more useful than this when they're out of order. Yes. So
Wait, how did you get the key? Well,
just pick any number. Instead of 68, I might have done 60, and I would have written 6/0 equals 60. So the people looking at the graph know what it represents.
okay.
Okay.
Do you want us to do the key?
Yes, please.
Okay,
Okay.
just for one, right?
Just one number. Yep.
Okay.
Then question number 3, we've got a list of absences. Here we want a frequency distribution. We want a histogram. And we want a mean, median, mode, and mid-range. What's different with this frequency distribution is we're not told to group the data. And so we'll have the absences. And this time I'm just going to put the frequency and not a tally because I don't have that much real estate here on the paper to work in. So my number of absences go from 1 to 12. And so now let's count up how many people were absent once. 1, 2, 3, 4, 5. So the frequency is 5.
There's 2 more. Oh, no, it's 11. Sorry.
Yeah. Then let's count up how many people were absent twice. 1, 2, 3, 4, 5. Absent 3 times, 1, 2. Absent 4 times, 1, 2. Absent 5 times, 1. Absent 6 times, 1, just 1. Absent 7 times, none. That'll be a 0. 8 times, 1, 2, 3. 9 times, 1, 2. 10 times, none. 11, 1, 2. And 12 absences once. I'm going to leave the table for a minute. For my histogram, the title would be class absences. My horizontal this is always my data value, so it would be the number of absences. My vertical axis is always the frequency. We could label it frequency, or we could label it number of students. Number of absences goes from 1 to 12. Highest frequency is 5. Let's go up to 5. And then, does everybody remember? A histogram is a bar graph. The height of the frequency, the height of the bar represents my frequency. I want my bars to be equal widths, centered around the number. So for 1, picture going from 1/2 to 1 1/2. Their frequency is 5, so we have a bar of height 5. 2, we'd have a bar of height 5. Remember, these bars need to touch, so they should be right against each other. Center at 3 will have a bar of height 2. Centered at 4 will have a bar of height 2. Centered at 5 will have a bar of height 1. At 6 we'll have a bar of height 1. There is no 7, so it's almost like having a bar of height 0 at 7. Then at 8 we have a bar of height 3. 9 we have a bar of height 2. 10 height 0. 11 height 2. 12 height 1. Remember, in a histogram, your bars must touch. The only time you might have a break is if there's a bar with a height of 0, something doesn't occur. How's the histogram for everybody? Again, you need a title and you need to label your axes. Otherwise, that graph has no meaning. For the mean, there's a couple of ways that you can do it. One way is if you really hit a lot of patients, you could just add all of those numbers. Another way, let me add the frequency 5, 10, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. The number of values is 25. We could just add those, or using the frequency distribution, we could take the value times the frequency to help us add. So if I have 5 1s, it adds up to 5. 5 2s would be 10. 2 3s would be 6. 2 4s would be 8. 1 5 is 5. 1 6 is 6. No 7s. 3 8s would add up to 24. 2 9s would add up to 18. No 10s. 2 11s would add up to 22. And then 12. And now if I add all of those, and I'm going to ask you guys to help me add. So when you add those, what do you get?
I got 116.
Okay, so did I. So the mean would be that total divided by the number of values, 25. And so the mean would be 4.64. For the median, we want the middle value. In order to find that middle value, we could take this list and put them in order. And you could rearrange those all in order. I'm a little lazy though. So in order to find the median, rather than writing them all out in order, remember we talked about the position of the median, and it was the number of values plus 1 divided by 2, which would give me 26 over 2. So it would tell me that it's the 13th number in my list. And so if my median is the 13th number in the list, I'm going to start listing my 5 ones, my 5 2s, my 2 3s, my 2 4s, and this gives me 1 2 3 4 5 6 7 8 9. Oops, I missed a 2. 10, 11, 12, 13. So the 13th number, the median, is 4, the 13th number in the list.
I'm sorry. I think I'm missing something. I've counted 24 values rather than
I
20.
had wrong. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yeah, there are 24. So thank you for catching that.
I'm sorry, I didn't see anything before.
So dividing, that would give me, that changes my mean a little bit, doesn't it? 116 divided by 24 would be 4.83. And then my position would be 25 divided by 2, which would be halfway between the 12th and 13th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Halfway between the 12th and 13th would instead make the median 3.5. Sorry about that. Thank you for correcting me. Next, the mode. The mode is a value that happens most often. It has the highest frequency. And so we have 2 modes here, both 1 and 2. And lastly, the mid-range, we said, is the highest value plus the lowest value divided by 2. So that would be 1 plus 12 over 2, which would give me 6.5. Excuse me. Is that all right? Once I corrected my arithmetic. Sorry about that.
How did you find the mode? I didn't see that.
The mode is the most frequent. So we're looking for the highest frequency.
Oh, yeah.
Okay. That question, all right.
So wait, did you multiply the absences and frequencies to get those numbers?
Mhm.
All right, and then the median, did you just take the 24 divided by 2?
I added 24 plus 1 and divided it by 2. 25 divided by 2 told me it was 12 and a half, which means it's midway between the 12th and 13th number in the list.
Is that a negative 12?
No, it's an equal sign that didn't come all the way through because of the stylus. I'm sorry.
All right. Okay.
And there is a question that asks you to find for a data set the mean, median, mode, mid-range, range, and standard deviation. In order to find the standard deviation, you can use the formula, which is the square root of the sum of the data values minus the mean quantity squared divided by 1 less than the number of values. And I put that formula there, but you don't have to use it. You can also make use of a table. And so I have the start of a table for you on the test to remind you what you need. And we have the data values, the mean, the data value minus the mean, and the data value minus the mean squared. And down at the bottom, we usually find the total of most of those columns. I have to apologize, the data here is old. This is a review sheet that I've been using for a while. I can't remember what year the turkey trot this is from, but I did go to the Buffalo News site and find the finishers, the first 10 finishers in the turkey trot. Since there's 10 of them, we know that our sample size is 10. Our data values are those ages, which would be 24, 31, 19, 22, 21, 21, 20, 21, 23, 23. In order to find the mean, you need to add those up. And please double check my addition because obviously I'm like Michael just waking up this morning too and a little slow. Let's see, 3, 6, 7, 8, 9, 10, 11, 25, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Did anybody get a total of 225?
Yeah.
And so our mean is that 225 divided by 10. So our average age is 22.5. And so I'm going to be a little lazy and not write it all the way down. This column here, the average is 22.5. In order to find the median, because this is a smaller list, there are only 10 numbers. Let's put our numbers in order. I think we've got one 19-year-old, one 20-year-old, 3 21-year-olders, 22-year-old, 2 23-year-olds, 24-year-old, and a 31. Middle of the list, the median would be halfway between 21 and 22, or 22.5. the mode.
Do you mean 21.5?
Yes, I wrote 21.5. Why did I say?
Okay, yeah, I see that. Sorry.
I'm sorry. Mode, the value that occurs most often is 21. Mid-range, if I take the highest plus the lowest and divide by 2, that gives me 25. And then the range isn't a measure of the center, but of the variation. It's the difference between the highest and the lowest. And so if I take 31 minus 19, my range is 12. Is everybody all right with mean, median, mode, mid-range, and range?
I was just wondering, do you always divide by 2 for the mid-range?
Yes. Then, for the standard deviation, we're going to finish this table. We're going to take each value, subtract the mean, and then I think I had told you folks previously that when I do these tables, I like to fill them in after this point sideways. Oh my heavens. Oh, for a second, I lost my calculator. 24 minus 22.5, I believe is 1.5. When I take 1.5 and square it, I get 2.25.
Excuse me, Professor?
Yeah.
When we do the test, do we have to remember to write these formulas on top?
No.
Okay, but we just, when we do our charts, I just
Yeah.
want to make sure.
Gina, I put this formula on the test for you.
Okay,
And I put this chart on the test for you to help you remember what you need to do for standard deviation.
okay,
Whether you use the formula or the chart doesn't make the difference. Main reason I put the formula on is because I want you to remember for the denominator, you divide by 1 less than the number of values. And that's what I always get from looking at the formula, if you divide by 1 less than the number of values.
okay,
Okay.
thank you.
And so then filling in the rest, 31 minus 22.5 would give me 8.5. And then with that in my calculator, if I just square it, I get 72.25. 19 minus 22.5 gives me negative 3.5. But remember, when you square it, it turns into positive 12.25. 22 minus 22.5 is negative 0.5. When I square it, I get positive 0.25. 21 minus 22.5 would be negative 1.5. Squared is my 2.25. Next one is also negative 1.5. Squares the 2.25. 20 minus 22.5 is negative 2.5. And when I take that and square it, I get 6.25. 21 we already did. Negative 1.5 squared is, I apologize, 2.25. 23 minus 22.5 would be 0.5. Squared is 0.25. And the other next 23 is also 0.5 squared, gives me 0.25. Now this middle column with the positive and negative numbers, check. If you use your signs, positive and negative, that column should add to 0. That next column, though, we do need to add. And so when we take 2.5 plus 72, add those numbers for me, folks.
So I come up with 100.5.
And anybody else get 100.5? I did also. And so our standard deviation is the square root of that total, 100.5 divided by, not by our 10, but one less than that, divided by 9. So with your calculator, you're going to take your 100.5 divided by 9, and then take the square root of that last answer. And so I get to the nearest 10th, 3.3.
Did you multiply those numbers together?
Which numbers?
The squared ones?
I added them
Oh, because I got 16 for some reason.
for this total.
Yeah.
Did you have all of these in this column positive, or did you have some positives and some negatives?
The only one I had negative was the 12.25, the first one.
Nope, they should all be positive. So if you add 2.25 plus 72.25 and so on, they should add up to 100.5. Check your addition. We'll give you a minute.
I have a question.
Sure.
It's not about this like at all. You know that a z-score graph?
Uh-huh.
Where can I find it on the textbook?
On what?
In the textbook?
The table
Huh?
or the normal curve?
The projectile.
Percentile?
Yeah, there we go.
The percentile table? The percentile
Yeah.
table in the textbook, I think it's on the first page of section 12. Oh dear, I'm having a brain fart. It's actually, let me take that back for a minute. Give me a second.
Okay.
Yeah, I keep getting 16.
It's on page, in the e-text, it's on page 822.
Thank you.
What are you adding to get 16?
All those numbers together.
What
Oh,
are
wait,
those
wait.
numbers?
Oh, no, wait, no, never mind. Was that 72?
Yeah,
Oh, I thought it was 12. No,
so it's 72.
no, I thought it was a 12.
Okay.
Never mind. Now I get it.
And make sure they're all positive. Does everybody comfortable with that standard deviation?
I was doing negative 12.25.
No, they're all positive. The reason we square them is to make them positive. This column should always be positive.
All right, yeah, I thought that was a negative in front of the.
No, it's
so-
72. Okay, we better now?
Yep.
That next question says that the mean height for adult males is 70 inches with a standard deviation of 4 inches. Find the height that represents 2.5 standard deviations above the mean. If it's above the mean, we're adding to the mean, and we want to add 2.5 times our standard deviation. So that would be 70 plus 2.5 times 4, which would be 80. Next one, because we want below the mean, we're going to subtract from the mean 1.5 times the standard deviation. And I think that's 70 minus 6, which would be 64. Last one wants half of standard deviation above the mean. So above, we're adding to the mean half of our standard deviation, which would give us 72. How's that question?
Can you just show that from the top again, please? I didn't really get it.
Say that again?
Can you just show that over like the whole number 5? Just go through it.
When it
Yeah.
says above the mean, we're adding to the mean. We're adding 2.5 times. This is the letter S for the standard deviation. So the mean is 70. We're adding 2.5 times our standard deviation is 4. Again, we're told the mean is 70. Our standard deviation is 4. So 70 plus 2.5 times 4 would give me 80. The next one, because it's below, instead of adding, we'll subtract. This time we're subtracting 1.5 times that standard deviation. So that would be 70 minus 1.5 times 4, which gives me
Oh.
64.
Okay, I get it.
Thank you for asking. We're going to make use of that line of reasoning to a certain point for the next question. Next question tells me the mean height for adult woman is 65 inches with a standard deviation of 3.5 inches. We're using the 68, 95, 99.7 rule. When I see that, I know to draw my bell curve, my normal distribution. When I do that, I'm always going to label my middle with my mean, which is 65. And then do you remember we add going across, we count up using the standard deviation. So 65 plus 3.5 is 68.5. Plus 3.5 would be 72. Plus 3.5 would be 75.5. Then in the other direction, instead of adding the 3.5, we subtract it. 65 minus 3.5 is 61.5. Minus 3.5 is 58. Minus 3.5 is 54.5. And then we group them. If I have one either side, we said that that's our middle 68%. Then if we go one to either side again, that's our middle 95%. And then the last grouping is our, I apologize, I ran out of group, the 99.7%. Please notice I did that without even looking at what the question asked. I did that because I was told to use that 68, 95, 99.7 rule. And it's easiest for me to use that rule when I look at this graphic. Everybody all right so far? So now, because I can, I'm going to play with colors. Next part asks me for the percent between 61.5 and 68.5 inches. 61.5 to 68.5. Does everybody notice that those numbers mark off one entire section? And that's the section that's 68%. Next question asks for between 65 and 72. 65 is my middle value. 72 is the end of 95. And so do you see, looking at the picture, what we're doing is we're taking half of that 95, which gives me 47.5%. Last one asks for the percent below 58 inches. Well, 58 inches is here. Below means to the left. And so notice that that's outside of the box for 95. And so we had said when we were going outside the box, we'll subtract by 100. And because we're only looking for one side, we'll divide it by 2. And so that gives me 5/2 or 2.5%. And again, this question is part of the reason, this question and the preceding ones were part of the reason that I wanted to give you a handwritten test instead of my math lab, because my math lab, each of these would be from a different data set. And I don't think you should have to redraw that picture over and over and over again. Drawing it once should suffice. Is everybody comfortable with these values?
Yeah.
Okay, good. The next question says a Gallup poll of 1,509 adults asked how much confidence they had in President Obama to do the right thing for the economy, and 71% said a great deal. And again, I apologize. You can tell that this is a really old question. I think this question is at least 8 years old. First part asks, what's the margin of error for this poll to the nearest 0.1%? Does everybody remember that your margin of error is 1 over the square root of the sample size times 100%. And so here, what is my sample size? How many people did we talk to?
$1,509.
1,509. So my margin of error is 1 over the square root of that 1,509. Then after I get the decimal, I'll multiply it by 100. And so with my calculator, I'm going to take 1 divided by the square root of 1509. And then when I multiply that answer by 100, I get to the nearest tenth, 2.6%. Everybody all right with that?
Yeah.
Then, next, do you remember we took that margin of error and we added it and subtracted it to our percent. So I'm going to take 71 minus 2.6, and I'm going to take 71 plus 2.6. Subtracting, I get 68.4. Adding, I get 73.6. And those are the numbers that I use for my statement. Again, because we're using this formula, our statement's going to start that we are 95% confident that between, and that's where we're using these numbers, 68.4% and 73.6% of, then we're going to finish it with the situation. Adults have a great deal of confidence. That I'm going to add Obama instead of president to put it in context. It was doing the right thing for the economy. And so here, you have to realize you're using the sample size to get your margin of error. You have to remember to subtract it and add it to the population percent. And you have to remember that we're going to be 95% confident that it's in between those values. This question, all right.
Wait, how did you get the 95% again?
We're always going to be 95% confident. The formula that we use is for the 95% level of confidence.
Oh, okay.
If it's a different level of confidence, then our formula for the margin of error changes.
Mm.
And so we want to kind of keep it simple. We're only going to look for that 95% level of confidence.
Okay.
That one, all right. If so, last question takes us back to what Michael was asking about at the beginning of class. We're given a set of data. We're given a mean and a standard deviation. You want to change them each to a z-score, remembering that the z-score is equal to the data value minus the mean over the standard deviation. And then we want to use those to find percentages. For the percent below is exactly my percentile, which I get from the table. So first, let's change that 142 into a z-score. 142 minus my mean is 121. My standard deviation is 15. That gives me 21 over 15, which is 1.4, I believe. Is everybody all right with that z-score?
Yeah.
So if my z-score is 1.4, we're going to go to the table. We're going to look for 1.4. And see that it's 91.2%. Did I copy that right? 91.92, I apologize. 91.92% below. Now we're going to do the similar work in terms of finding the z-score for 130. The z-score for 130 is 130 minus 121 divided by 15. 9 over 15 is going to give me, I think, 0.6. And so 0.6 from the table is 0.60 is 72.57%. So that's 72.57% below. But the question doesn't ask for below, it asks for above. For the percent above, does everybody remember we're taking 100 minus the percentile? And so when I take 100 minus 72.57, I get 27.43%. Somebody check my subtraction, please.
That's what I got.
Okay, thank you. Because when I do things in my head today, I'm making careless mistakes. I'm sorry, guys. So now I'm going to cheat a little bit. I think this 112 should be 142. And so for the percent between, it's going to be the differences of percentile, which are the
Wait,
numbers that we get.
Isn't that 27.43 supposed to be above?
Thank you. It is supposed to be above.
Oh.
I was so worried about my subtraction being wrong that I wrote it wrong. Thank you very, 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 very much. I owe you. Sorry. So the percent between is the difference of the percentiles, the numbers from the table. And so for 142, we had 91.92%. For 130, we had 72.57%. And so when I subtract, I get 19.35% between. And somebody check my subtraction. Am I writing?
Yeah, I got that.
Okay. And that's it. That's what you should look for in that test, which should be available for you folks, I believe, starting tomorrow morning. Let me double check. How are you? Any questions on that stuff? I'm looking at my clock and I'm seeing that it's that time anyways. So if you need to go, if you have additional questions, I can stick around for you. I take that back. I think that test is available for you right now. So anytime after class today. Does anybody have questions on any of this?
So is there only 18 questions on the exam?
No, there's only like 8 of them. The reason it's 18 is because I'm not good with spacing. Some of them have alphabet soup parts. There's only 8 or 9.
All right.
Okay.
Okay.
It's the length of what we just did. You have 75 minutes, which is a regular class time, 1 hour 15.
Okay.
Okay. Anybody come late that I did not get on attendance? No?
On my last quiz, did you see my work that I uploaded?
Was the work in Blackboard?
Yeah,
Yeah, then I did look at it.
because I don't see the grade for it.
Okay, well then let me double check. I'll check that as soon as we're done. Okay?
Okay.
Oh, you know what? While you're right here, let me go into the grade center. Let me go into the full grade center. Let me look for you. Let me go all the way to the central tendency quiz. Yeah, you've got a grade in there, huh?
Oh, really? Because I was looking at my grade and I only saw the one for like the work online.
Oh yeah, the grade for the work is the quiz grade.
Oh, so it's already in there?
Yep. because the grade, the grade for the work is the quiz grade. That's where I submit the work. It's not the grade that's in Blackboard. It's the grade for the work.
Oh, oh,
Okay.
all right.
All right.
All right, just one question, Professor.
Sure.
I remember you telling us that the test was due by Sunday, that's the 22nd. It says here, however, on Blackboard that the test is due on the 23rd at like 11:53 a.m. Will you be keeping that new time or will you be taking it back to the 22nd?
I guess if I have it typed in there as the 23rd, I'll leave it.
Okay, thank you.
Okay. You know what? I think I have it due a Sunday night, but I think it's, the thing is going to be open in Blackboard until Monday in case people have problems uploading.
Oh, okay, great.
Okay.
I'll keep
I
that in
usually give before it disappears, I give a little bit of leeway time in case people have technological problems.
All right, I understand. Thank you very much. Have a good day.
You too. How about the last three of you? Is there anything I can do for you, Lucas, Demia, or Ali?
Did you get me in attendance?
I believe I did. Because you were bouncing in and out because of technical problems. I think at one point in time you were in class twice, right?
Yeah.
So let me just double check and make sure. I do remember though going back and making sure that you were in, but yep, I got you, hon.
Okay. Talk to you later. Bye. Thanks.
Bye-bye.
Yeah, I just wanted to say that I had to leave, or my computer shut down because it died on me.
Oh, I
So
hate when that happens. I'm glad you came back.
yes.
Okay, we got you. Did you get everything that you needed from the review?
Yes, I think I should be good.
Okay, good.
Thank you.
Okay, have a good one. Ali, how about you? Are you there? All right, goodbye.